Have you ever looked at a blueprint for a giant skyscraper and just thought, how? How does all of that fit onto a piece of paper? Well, it turns out there's a kind of secret language that designers use to make it all work. It's called architectural scale, and today we're going to decode it together.
Seriously, think about it. It sounds like a magic trick, doesn't it? Taking something unimaginably massive and shrinking it down so you can hold it in your hands, all while making sure every single little proportion stays absolutely perfect. The answer, though, is both brilliantly simple and incredibly powerful.
Yep, the solution is pretty obvious. You shrink it. But, and this is the important part, it's not just any old shrinking. It's a precise mathematical code. It's a whole system for translating the gigantic into something we can actually work with. And that code, that's architectural scale. At its core, it's just the process of shrinking real-life stuff down proportionally so that a building, or hey, even an entire city, can be drawn accurately. It's really the essential tool that lets an idea travel from an architect's mind to a builder's hands.
So, how does this whole code actually work? Well, deep down, it's all about a simple ratio. The scale is just the size of something on the drawing divided by its size in the real world. That little formula, that's the key to everything.
Okay, let's take a super common example you'll see everywhere. A scale of 1 to 100, written 1/100. That literally just means that one unit on your piece of paper, say 1 centimeter, represents 100 of those same units in reality. So 1 centimeter on the page equals 100 centimeters, which is, 1 meter. It's that simple. Everything is exactly 100 times smaller.
And once you get that basic idea, you can start to really read the language of scale. You'll see different ratios are used for different jobs, kind of like using different lenses on a camera to zoom in or zoom out.
So check this out. This cable really shows you those zoom levels in action. At a 120 scale, you're zoomed way in, looking at the fine details of a piece of furniture. A 1/100 scale is kind of your standard view for a house floor plan. And then you zoom all the way out to 1/1000. Now you're looking at a master plan for a whole neighborhood.
Now, if all these numbers feel like a lot to take in, don't worry. Here's a fantastic little trick to remember the common ones. Just think of them like coins. 1, 2, 5, 10, 20, 50. It's a simple way to make those standard scales stick in your head.
Oh, and a quick heads up, while most of the world uses that simple metric ratio we've been talking about, you might run into the imperial system, especially in the US. The logic is exactly the same, but it looks a little different. Instead of a ratio, it'll say something like 3 inches equals 1 foot. Okay, so that's the theory. Now let's get into how this all works in practice. How do designers actually decide which scale to use and when?
Choosing a scale isn't just a random guess. Architects are actually thinking about 4 key things. First, how big is the actual object? Second, how much detail do they need to show? Third, what size is the paper they're going to print on? And fourth, where are they in the whole design process?
Now here's where scale gets really, really cool and maybe a little mind-bending. Let's say you take a simple line and you scale it down at 110. Pretty straightforward, right? Its length just becomes 10 times smaller.
But what happens if you have a 2-dimensional area, like a square room? Well, you're not just shrinking the length by 10, you're also shrinking the width by 10. So the area isn't 10 times smaller, it's 10 times 10. It actually becomes 100 times smaller. See where this is going?
So the effect totally changes depending on the dimension. If a 2D area shrinks by a factor of 100, what do you think happens when we go to 3 dimensions with a cube?
Yep, it becomes 1,000 times smaller. 10 times 10 times 10. This is the real magic. This is why a tiny little model on a desk can perfectly represent a massive, sprawling building. The reduction is just immense.
And all of this leads to a much bigger idea. Scale isn't just a tool for drawing. It's a fundamental tool for thinking. It's what allows a designer to jump seamlessly from the huge scale of a city right down to the tiny scale of a single brick. And this timeline just illustrates that journey perfectly. A project might start way zoomed out, at 1 to 1,000, just looking at the whole site. Then they zoom into 1 to 500 to figure out the basic shapes. Then in again to 1 to 100 for all the floor plans. And finally, they might zoom all the way into 1 to 10 to figure out exactly how 2 materials are going to be joined together.
But just writing a number on the page isn't the only way to show scale. It's also about visual clues. A scale bar is essential, of course, but adding things like little figures of people or some furniture or trees, those are the things that humanize the space and give you an instant, intuitive feel for its real size.
I think this quote really just nails the whole idea. Scale is a tool for focus. It lets a designer filter out all the unnecessary noise and just concentrate on what really matters for that specific task at that specific moment. It's all about clarity.
So next time you see a floor plan or a map or a model of a building, you won't just see a drawing anymore. You'll see this elegant, powerful language at work. You'll understand the code. So the real question is, now that you know it, how is that going to change the way you see the world all around you?